Welcome to my class. In the previous video, I explained the general greedy method. Now in this video, I am going to explain the example of general greedy method. So that example is knapsack problem. So what is knapsack? First, I will explain what is knapsack problem. What is the aim of knapsack problem? I will explain. After that, I will take one example and I will explain, or I will show you how we can construct a optimal solution. Okay. So what is knapsack? First of all, so knapsack is a bag. Sorry. Knapsack is a bag. Okay. So this problem, knapsack problem is containing items with weights and profits. Item with weights and profits. So here we are taking a set of items, and each item is associated with its own weight and its profit. If you select that particular item, and generally we are taking a bag. So aim is filling bag first. Filling bag by selecting these items, one item after another item, because according to greedy method, we are approaching this particular problem solution stage wise or step wise. But each step we are going to select one item, and once you consider this item completely, then this particular weight must be consumed in the bag. Because we are going to place this particular item into the bag. Once this item is completely considered, then we get the total profit of the respective item. Okay, na? So the aim of this knapsack problem is to construct a solution x1, x2, so on, xn. Suppose your problem is containing n items. Then we are going to construct the solution of the first item, solution of the second item, so on, solution of the last item. Okay, na? So combinedly treat it as a solution for the knapsack problem now. Then how can we construct solution? So x1 is the solution of first item, x2 is the solution of second item, so on, xn is the solution of the last item here. Okay, so I have already told, suppose there are n items, first item, second item, third item, so on, nth item, and each item is containing its weight. Suppose W1 is the first item, W2 is the second item, W3 is the third item, so on, Wn is the nth item. If you consider item completely, then we get the profit as P1, profit as P2, third item profit is P3, so on, last item profit is P. This is problem. Okay, na? Items are there, items respect to weights are there, and items respect to profit is there. Okay, na? So this is the problem. Then ultimate aim is, what is the ultimate aim? Getting maximum profit in the item. Getting maximum profit from this particular problem is the aim. Okay, so I already told in optimal solution definition. What is optimal solution definition? What is optimal solution? Whatever the solution you construct, if that particular solution maximizes objective function. What is objective function here? Profit. Maximizing profit will be the objective function. Our objective is to get the maximum profit from this particular problem. Okay, na? Maximum profit from this particular problem. But here we select all the items in the sequence. Okay. So here we need to construct a solution now. Solution is optimal solution. Solution is optimal solution. And from all the feasible solutions, of course, we can also go a straightforward manner for constructing optimal solution. We can also approach finding all the possible feasible solutions, and we can select one particular solution which produces maximum profit out of all these feasible solutions. What are feasible solutions? What do you mean by feasible solution? The solution which satisfies the given constraints is called feasible solution. So here we are taking a bag for keeping all the items. So we say this bag is containing its own mass or capacity. Every bag is containing its own mass or capacity. Okay, na? So we are supposed to select all the items in such a way that whatever the items which are included into knapsack, the total weight of included items weight should be less than or equal to this mass. Is it clear? No, total weight. So that particular weight is depending on the solution. Okay, I will tell you how we can construct xi. So what is xi? Xi is the ith item solution. So how can you get ith item solution now? Suppose, what is weight of ith item? AA is weight of ith item. Suppose if remaining knapsack capacity, after placing I minus 1 items, some capacity may be remained. Suppose, let us assume that remaining knapsack capacity is R. Remaining knapsack capacity is R. Okay, na? And WA is ith item. We have already placed I minus 1 items now. Okay. Suppose if R is greater than or equal to WI, still there is a space to accept the entire item completely, then the solution is out of Wi, we can select Wi weight. Out of Wi, we can select Wi weight. Then what is Xi now? Xi solution is 1. That means we are completely considering the respective item. Completely considering respective item. Otherwise, suppose R is the remaining knapsack capacity and Wi is the next item weight. We have already placed I minus 1 items completely. And R is the remaining knapsack capacity after placing I minus 1 items. And the next item to be included is ith item, and ith item weight is Wi. Suppose if R is less than Wi, we cannot place or we cannot consider ith item completely. Okay, na? Then we can extract a fraction from this. Suppose remaining knapsack capacity is R units. You are supposed to extract R units from this. How can we extract R units? Out of Wi, we are supposed to extract R units. R is the remaining knapsack capacity. Wi is total item weight, but this item is not completely fitting into knapsack because the remaining knapsack capacity is less than item weight. So that's why we cannot place this item completely into the knapsack because knapsack can hold only R units weight. But item weight is Wi units. The relationship between item weight and R is R less than Wi. So that's why we cannot completely fit the item completely. So the solution becomes Xi equal to R by Wi. How we get Xi equal to R by Wi? What is R? The required weight from the item because this is the remaining knapsack capacity. We cannot place Wi units completely into knapsack. We require only R units. Here we can place total weight into knapsack because the remaining knapsack capacity is greater than or equal to Wi. That's why we can consider ith item completely. So out of Wi, we can select the full item, so Wi units. But what happened here? R is less than Wi. So we can extract only R units from Wi. Then the solution becomes we can extract R only out of Wi units. So required is R units only out of Wi. Then the solution becomes Xi equal to R by Wi in this case because here remaining knapsack capacity is less than item weight. But here Xi solution becomes 1 because out of Wi we can select complete weight. That's why item weight by remaining item weight by item weight or extracted item weight by item weight, that becomes the solution of each item. So like this we can calculate. So solution of each item Xi can be calculated by first considering how much weight is remained in the knapsack and how much the weight is there for that particular item, and verify whether we can completely place that particular item into knapsack or not. If it is okay, then solution becomes 1 because out of Wi we can select all Wi units and we can place that item completely into knapsack. Otherwise, we need to verify if it is not possible to place the item completely, then how many units are remained in the knapsack. Based on that, we can calculate solution. That solution is remaining knapsack capacity by item weight. This becomes a solution. So otherwise, if after placing ith item, bag is completely filled, then Xi plus 1 to Xn becomes 0 because we cannot select all the remaining items. So X1 to Xi we selected. Up to Xi minus 1 we have completely placed items into knapsack. Complete items into knapsack. But ith unit, ith item, suppose this is the scenario, then we get a fraction solution. Once bag is filled by selecting first item to ith item, then what about the solution of Xi plus 1 to Xn? We cannot select the remaining items. Then X becomes 0. So out of Wi plus 1, we can select only 0 units. Then 0 by Wi, 0 by Wi plus 1, 0 by Wi plus 2, so on, 0 by Wn, all are become 0. So like this we can calculate the solution of any problem under knapsack problem. Then now I am going to explain there are 3 possible ways for constructing solution for knapsack problem. One is applying brute force approach. Brute force approach means by applying all the possible solutions, we can select out of all these possible or feasible solutions, we can select one solution is the optimal solution. And another way, remaining 2 are straightforward approaches. One approach is just every time the selection criteria is like in general greedy method. I've already explained select of A. Select of A means that select procedure is always used for selecting one item from the knapsack. Here also the selection criteria is always we select maximum profit item first. irrespective of the weights, whether that particular item weight is greater than or less than the remaining items or not. So first we select maximum profit item first and place it completely. Suppose if the item weight is less than knapsack capacity, place it completely and go to next maximum profit and so on. So in this particular method, we are supposed to arrange all the items in profit decreasing order. So, but always we cannot get optimal solution if we follow this particular approach. But alternate is with slight modification. Just first calculate profit and weight ratios. Calculate profit and weight ratios of each and every item and arrange all the elements in such a way that all the elements which are included into this particular order should contain profit by weight ratio in decreasing order. So whatever the item you select in first position, that item weight profit and weight ratio should be greater than second item. Second item profit and weight should be greater than or equal to third item and so on. In such a way, if we arrange all the items, ultimately we get the optimal solution. So there are three possible ways we can construct solution for knapsack problem under greedy method. What is the first procedure? Just calculating all the possible solutions and selecting one possible solution as optimal solution which is having maximum profit. And second method is arranging all the elements in profit decreasing order and select in that particular order. They select all the elements in that particular order and possibility is there, include all the items completely. If there is no possibility of including the item completely, then select the fraction like this and assign the rest of the item solution as 0. And third one is because always we cannot get the solution from the second problem. Optimal solution we get, but optimal solution we cannot guarantee in second approach. In third approach, suppose if we arrange all the elements in profit by weight ratio decreasing order, if you select all the items in that particular order, ultimately we get the maximum profit. Now I am going to show the profit calculation under knapsack problem by taking one simple example. Okay, so first of all, before going to explain this problem, I am going to show, so what is the problem statement now? So what is the aim of knapsack problem now? So maximizing the maximum profit. But what is the constraint here? So whenever you are going to include any item into knapsack, so that inclusion should not increase or excess the capacity of knapsack. Then I can write the problem statement like this. So what is the maximize? Maximize what we are going to maximize the profit summation of PIXI. So summation of PIXI, PI is each item profit where I is varying from 1 to n. So if we multiply solution with profit, we get the total profit from that particular item. If we consider item completely, we get the total profit. If we consider item fractionally like R by WI, then we get the profit PI into R by WI only. Suppose remaining knapsack capacity is R units, but the ith item weight is WI. Okay, na? We cannot accept here WI is greater than R. We cannot place the complete item into the knapsack. That's why we cannot get the complete profit. We cannot get complete PI. How can we get how much profit we get? PI into R by WI we get. PI into R by WI. I will give one example. Suppose remaining knapsack capacity is 2 units. Remaining knapsack capacity R equal to 2 units. Suppose item weight WI equal to 4 units. Item weight WI equal to 4 units. And profit PI equal to suppose 6 units. Ith unit profit is 6 units. Ith unit weight is 4 units. But remaining knapsack capacity is 2 units only. Can we place 4 units item into knapsack? Knapsack no. Because knapsack is like a bag. Knapsack is like a bag. Okay na? Up to this moment we included I-1 items completely into knapsack. But at the time of selecting ith item, okay, the remaining knapsack capacity is only 2 units, but ith item weight is 4 units. From this we get 6 units profit. How? So when we got 6 units profit, if you select item completely, then we get complete profit. But what will happen here? The remaining knapsack capacity is 2 units only. So I have already explained the solution as remaining knapsack capacity by WI if WI is greater than R, otherwise XI becomes 1, because if remaining knapsack capacity is greater than or equal to item weight, we can completely place the item into knapsack, then complete weight is going to be consumed. Then we get solution as 1 and the complete profit we obtain. But what is happening here? XI is R by W. What is R? 2 by 4. 1 half only. 200 2 2 say half only. Then we cannot get total profit 6 into 1 by 2. So PI into XI. the profit we can extract from the respective item is Pi into X. Just simply multiply profit with the solution. We get that much profit. Is it clear now? So we get only 3 units profit. Suppose remaining knapsack capacity is 4 units. Item weight is also 4 unit. Then what is solution now? Wi by Wi. Out of Wi, you can select Wi units directly because capacity is 4 units. Item weight is 4. We can completely consider the item. Then Xi becomes 1. Then 1 into 6. Complete profit we get. So like this we can select all the items. In such a way we can select all the items. But finally you must get maximum profit. Then what is the subjective here? Whatever the items you include, those items total weight should not increase or should not cross the capacity of knapsack. So maximize. So the statement of knapsack problem is maximizing PIXI subject to summation of WIXI. Summation of WIXI less than or equal to, suppose mass or bag capacity is m units. Then this is the constraint. Whatever the items you select, those selected items weight should not increase m. That must be less than or equal to m. Is it clear now? So this is the constraint. Based on this, get the maximum profit. What is Xi now? Xi may be either 0, 1 or fraction. We get fraction if knapsack capacity is less than the item weight, we get fraction solution. Otherwise, sometimes if up to ith item, after placing ith item into knapsack, if knapsack is completely filled, then whatever the solution of I plus 1 to n, I have already told. I plus 1 to n solution is 0 because we cannot select even fraction from that. If we completely consider the item, then solution is 1. If we completely omit the item, solution is 0. If we extract the fraction solution, then Xi gets the remaining knapsack capacity by item weight is the solution. So these are the 3 different solutions we get under Xi. One is 0 if we omit the item completely. Another one is 1 if we consider item completely. Otherwise, Xi solution is fraction. How can we calculate fraction? Remaining knapsack capacity by item weight. Okay, na? Like this we get the solutions. In this way we can calculate the solutions, and the problem statement is, what is the aim of problem? Maximizing the profit. How can we calculate total profit now? If you select Xi from the weight or item, then we get that much proportion only from the profit. If Xi equal to 1 means if we consider item completely, we get complete profit. If we omit completely, we get 0 profit. If you consider the fraction from that particular weight, this fraction only we get the profit. Pi into R by Wi profit we get. Otherwise Pi. So that's why we write total profit we can obtain from this particular problem is PIXI, where I is varying from 1 to n. Then if we expand it, then P1 x1 plus P2 x2 so on Pn xn is the total profit we can obtain. With respect to W1 x1 plus W2 x2 so on Wn xn less than or equal to m, where I is varying from 1 to n. So this is the problem statement. Once again I will tell you the problem statement as maximizing the total profit, obtaining from that particular problem after solving. With respect to or subject to all the items which are included into knapsack, the total weight should be less than or equal to m. So that's why we can write that statement as subject to summation of I equal to 1 to n Wixi less than or equal to m. So where Wixi is the total weight included into knapsack from the items, and Pixi is the total profit we can obtain by including those items. Okay, na? So where Xi is varying from 0 to 1 and I is there in between 1 to n, because the number of items are n, start from first element and up to nth element we can select. If there is a possibility of selecting completely, then we can completely include the item. Otherwise we can calculate fraction amount. Okay, so this is the problem statement. Now I am going to explain the problem now. Now I will take one example and I will show you by constructing all the possible solutions and selecting one solution as optimal now. Okay, so my intention from the first solution is, suppose if you don't fill the knapsack completely, then we get the less profit. So my intention for constructing first solution is, just if you compare all the remaining solutions with the first solution, because first solution the bag is not completely filled, only 16.5 units are filled completely. Here knapsack capacity m equal to 20. Knapsack capacity m equal to 20. The number of items are 3 and first item weight is 18, first item profit is 25, second item weight is 15. If we completely consider 15 units, then we get total profit. Then third item weight is 10 units. If we completely consider third item, then only we get 15 units profit. Okay na? So this 25 is, if you consider item completely, then only we get 25. If you consider the item completely, second item, then only we get 24 units profit, like that. Okay na? Otherwise, if you consider fraction, then we get the same fraction from the profit. Okay. So now, so my intention of showing the first solution is, if you don't fill the knapsack completely, then we get less profit, because if you compare this solution with all the remaining solutions, this solution is smaller. This solution is lesser than the remaining solutions. Okay na? Then the remaining possibilities are, suppose if it first is, if you take half of the item from the first unit, first item, 1/3 from second item, and 1/4 from third item, what is half? Half weight is 9 units. Plus, what is 1/3 into W2 into X? What is X? 1/3. Then 3 5s are 5. Plus W3 into X. This is the included weight. Included weight. How can we calculate included weight? Summation of WIXI. This is the included weight into knapsack. So W1 into X1. W1 is 18. X1 into 1/2 means 9 units we extracted from first item. 1/3. 15 into 1/3. That is the item weight included into knapsack. 15 into 1/3. 5. Plus 10 into 1/4. That is the item weight extracted from third unit. Third item. So 10 into 1/4. 2.5. So how much? 16.5. Only 16.5 units are included into knapsack. Then how much profit we get? Same. Summation of PIXI. Summation of PIXI we get. So what is P1? 25. What is X1? 1/2. 25 into 1/2 plus 24 into 1/3 plus 15 into 1/4. Only that much profit we get. Then the total profit we obtain by that solution. This is one solution. That solution is 24.25. So that is my intention, to show if you don't fill the knapsack completely, we get the less profit. That's why I took that example. And after that, for the remaining examples, I am filling knapsack completely. The knapsack is filled completely, but out of these three possibilities, I am going to select one possible solution. That solution is optimal. This is optimal solution because this is greater than the remaining two solutions. Okay na? So first way is brute force, means I select all the possibilities, apply all the possibilities. Then first case, select first item completely. If you select first item completely, then 18 units are consumed. 18 units are consumed from first item. How much profit we get? 25 units profit. This is profit. Weight consumed is 18 units. Then the second item. What is the second item? How much remaining weight? 18 units are already over. Then only 2 units are remained. Only 2 units are remained. Then we are going to extract 2 units from 15. So what is the solution? X1 equal to 1. What is X2? Only 2 units are remained out of 15. We are going to extract 2 units from 15. I have already told you how to construct solution for the item. Remaining knapsack capacity is 2 units. 2 is less than 15. In that case, we are supposed to construct the solution as remaining knapsack capacity by item weight. So that's why 2/15. Okay na? Then by using these two, we can get 2 units from this. So 18 plus 2, 20. So 20 units are consumed completely. Then how much profit we get? 25 plus 24 into 2/15. 24 into 2/15. Then we get 25 plus 3.2. Then we get 28.2. Whatever third item solution, bag is already filled with first two items. Then we cannot place third item. Then we cannot extract any portion from the third item. So that's why third item solution is 0. So this is one possible solution. Yes, this is feasible because bag is completely filled. This is one feasible solution. What is feasible solution? Ultimate aim is filling the bag is first case and getting the maximum profit. So that's why this is feasible solution, one feasible solution. And from this, if you follow this solution, then we get 28.2 units is the profit. Second possibility is, of course, we can also make this is 1 and make this as 0, and extract the portion from third item. Suppose if you one more solution I will write. Suppose with respect to 2, suppose if you consider first item completely, and if you omit the second item and third item, from the third item if you want to extract the fraction, means first item weight is 18 units, second item we omitted completely. So x1 equal to 1, x2 equal to 0. What is x3 now? Remaining capacity is 2 units. Remaining capacity is 2 units and the item weight is 10 units. Then what is the solution now? X3 is remaining capacity by item weight. Remaining capacity by item weight. From this we get 2 units. Then 20. Bag is filled completely. According to this, one more possibility. Making 1 here and taking a fraction from this and making second item completely omitted. Okay na? Then what is the third item solution now? 2 by 10. So this is the solution. x1, x2, x3. 2 by 10. Then item is completely, bag is completely filled with this. Then how much profit we get? So what is the first item profit? 25 into 1 plus 24 into 0 because we omitted completely, plus what is the third item profit? 15. 15 into 2 by 10. 15 into 2 by 10. So 25 into 1, 25 plus 0 plus 5 3s, 5 2s means 3. 28. Okay, one more solution. If we add that solution also, then we get 28 is the solution. Like this, apply all the possibilities. Making, selecting one item completely and extracting a portion from second item, and considering first item completely and omitting the second item and extracting remaining portion from the third item, and again omitting first item completely, selecting second item completely, considering second item completely and extracting a portion from the third item, and again considering second item completely, omitting third item completely and extracting portion from the first item, like that. So these are the possibilities. Then what about next possibilities? Here in third solution, I am omitting item completely and I am considering third item completely. If you consider third item completely, how much weight is consumed? 10 units weight. Okay, na? So I omitted first item completely. This is the solution. Of course, this solution. I am omitting first item completely. Then weight is WIXI is, so W1 X1 is 0. What is W2 X2? W2 X2 is 2 by 3 units. I am extracting 2 by 3. So 15 into 2 by 3. This is the weight extracted from second item. Whatever third item, I completely consider third item. 10 into 1. So 0 plus 3 5 10 plus 10 20. By using this, I can fill the knapsack completely. But how much profit I can get? So 0 or 25 into 0. 25 into 0 plus 2 by 3 into 24. 24 into 2 by 3 plus 1 into 15. 1 into 15. So 25 into 0, 0. 3 8 24. 8 into 2. 16 plus 15. How much profit I get? 31 units profit I can get. 31 units profit I can get. Okay, na? So total profit we can extract from that particular item is PAXI. Total weight that is consumed in the bag from that particular respective item is WIXI. If you completely consider the item, then the total weight is consumed in the bag. From that we get total profit. If you extract only fraction portion, the same fraction portion we need to extract from the profit. Okay. So what is the third solution? Third solution is I am considering first item completely. I am omitting. I am considering second item completely. I am omitting first item completely, and half of the portion I am extracting from the third item. Then how can we construct the solution? 18 is 0 because I am not considering any portion from the first item. I completely considered the second item means 15 units I considered. The only 5 units are remain. From that 5 units I am extracting from 10. Then solution becomes 5 by 10. 5 by 10, then 1 by 2. 5 by 10, 1 by 2. Then 15 weight. Weight is 15. 20 weight. But what about profit? First item omitted completely. Then this is becoming 0. Plus second item completely considered. This is 1 means 24 units I get. Whatever third item, half of the portion I extracted, then 15 into 1 by 2. 15 into 1 by 2 means 7.5. So 24 plus 7.5. How much? 31.5. So like this we can construct the solution. So this is not only this. I can consider first and third item completely. I can consider second item. I can omit third item completely. I can extract the fraction from the first item. Next, here also I can consider first item complete, second item completely. I can omit third item completely. I can extract the third item. Like this, I can extract a fraction from first item. Like this, construct all the possibilities. Construct all the possibilities by considering one item completely and omitting one item completely and extracting the portion, and change the consideration. And consider all the possible solutions and make them as feasible, because how can you say that solution is feasible if bag is completely filled? This is not feasible solution because here the bag is not completely filled. That's why we got less profit than all the remaining weights. Generally we get the acceptable profit if bag is filled completely. But out of those feasible solutions, we are supposed to select one solution. That solution the solution profit should be greater than the profits of all the remaining solutions. So out of these 4 solutions, this solution profit is greater. That's why, what is the solution now? Solution should be represented in terms of x1, x2, x3. What is x1 0? What is x2 1? What is x3 half? What do you mean by this? Completely omit the first item, completely consider the second item, and select the half of the portion from the third item. Half of the portion means 5 units. 5 plus 15, 20 units. From this we can fill the bag completely. But what about profit? Completely omit this. Then we lose 25 units profit. But completely consider this. Then 24 units profit we get. But half of the portion we can extract. Because half of the weight only we considered. Then from the profit also we get half. Half means 7.5 plus 24, 31.5. So out of these 4 solutions, this solution is treated as optimal solution. Okay, this solution is treated as optimal solution. Okay, now I will tell the remaining 2 possibilities, and out of those 2 remaining 2 possibilities, I will tell you which is a good method for constructing the solution. So in brute force means by considering all the feasible solutions, and we can construct like this. Of course, only 3 items are there. Then just by constructing 6 solutions, we can say that, this is the optimal solution. But I constructed only 4 here, because just by changing 1 position and 0 positions, we can construct all the possible solutions. Only 3 items are there. It is possible constructing all the possible solutions by constructing table. But there is another method. If number of items are more, then there is another method, that is straightforward approach. Just by applying straightforward approach, we can directly get the solution. But we don't know, we don't give guarantee, because straightforward greedy approach may or may not produce the optimal solution now. Okay, I will show you a straightforward approach. That is straightforward first approach. So in straightforward first approach, we must arrange all the elements in profit decreasing order. So profit decreasing order. Luckily we have profit decreasing order. All the elements are there in profit decreasing order only, because first item profit is 25, second item profit is 24, third item profit is 15. Third item profit is 15. Okay. So the same order we need to consider. First select maximum profit item first. First select maximum profit item. If select maximum profit item, how much weight is consumed? W1, X1 weight is consumed. Where X1, what is X1? X1 equal to 1, because we completely consider first item. Then from this, the total weight consumed is W1 X1. Then 18 into 1. 18 into 1 is 18. Then what is the capacity of knapsack? M. M minus W1 X1. This is remaining knapsack capacity. So 20 minus 18 is 2. So R is 2. R is 2. Then select maximum profit item. Next maximum profit item is 2. But what is the weight of next maximum profit item? 15. Remaining knapsack capacity is 2 units only. But we cannot place 15 units item completely. Then what is the solution now? Remaining knapsack capacity by item weight. X2 equal to 2 by 15. Then how much profit we get? From the first item we get 25 units profit. Profit we get is P1 X1, 25 units. Then what about P2 X2? P2 X is 24 into 2 by 15. 24 into 2 by 15. 3 5 is 3 8 chat. 16 by 5. 16 by 5 is 3.2. Okay, na? So bag is filled now. So with W1 X1 and W2 X2, the bag is completely filled, because 18 plus 2 equals 20. We cannot place third item. We cannot place third item. So third item solution is 0. So according to straightforward greedy, this is straightforward. I am applying straightforward greedy approach. So in straightforward greedy approach, if you apply straightforward approach on knapsack problem, straightforward approach always selects maximum profit item first. So maximum profit item is first item. If you select first item completely, that particular knapsack is consuming 18 units weight. From this we get 25 units profit, because I considered item completely. Then total profit obtained is P1 X1. So 18 into 1, 25 into 1, 25 units I get. Then what about remaining knapsack capacity? Mass is 20 units and 80 units are already consumed. Then 20 minus 18 is 2 units. Now I am going to select next maximum profit item. Next maximum profit item is second item only, but second item weight is 15. I cannot extract 15 units directly. I cannot place 15 units item directly into knapsack. I can place only 2 by 15th portion from the second item. So then only I get 20 units completely. Then profit I can get as 2 by 15th only. So 24 into 2 by 15, that is 3.2. Then total weight up to second item is 20. Then bag is completely filled. Then I cannot place third item. So third item is 0. So what is X1? X1 is 1. What is X2? X2 equal to 2 by 15. X3 equal to 0. This solution. Second solution in that approach. Okay. So from this, how much profit I can get? One is 25 plus 3.2 because P1 into x1 plus P2 into x2 plus P3 into x3. P2 into x2 is 3.2, P1 into x1 is 25, P3 into x3 is 15 into 0, 0. So 28.2. But what is according to brute force approach? According to brute force approach, we got 31.5 units profit. But according to straightforward greedy approach, if you follow straightforward greedy approach, it produces 28.2. That's why what I want to say is, if you apply straightforward greedy approach, sometimes it may not produce optimal solution. Then I can slightly change this straightforward greedy approach. Instead of arranging all the elements in profit decreasing order, if we arrange the elements in profit by weight ratio decreasing order, we can get the optimal solution. I will show you that one also, and through that I can say, if you arrange all the elements in profit by, first we need to calculate profit by weight ratio, because here I didn't consider, according to this I didn't consider whether weight is greater than all the remaining items or not. Just based on profits, I selected all the items. I omitted considering weights, but while calculating a total consumed weight, I am considering. But but at the time of selecting the items, I am not considering. I need not bother about the weights of the items. Just I considered based on highest profit items. Profit based on profit I considered. Now calculate profit by weight ratio. Now first is calculate P1 by W1. P1 by W1 is 25 by 18, that is equal to 1.3. Now calculate P2 by W2, 24 by 15, that is 1.6. Next P3 by W3, 15 by 10, that is 1.5. Now consider these values. Consider these values and arrange all the items in profit by weight decreasing order. So Pi by Wi should be greater than or equal to Pi plus 1 by Wi plus 1. In this way, we need to arrange all the items. Okay, na? So which item is going to which item comes first? Second item, because second item profit by weight ratio is 1.6. So second item weight is 15. Second item profit is 24. Now second item becomes first item in this order, updated order. Then what about third one? The third one becomes second item in the updated order, and first one becomes third item in the updated order. So once after arranging, like the previous one, once after arranging all the elements, then blindly select the elements in the same order, like the previous example. Like after arranging all the elements in weights profit decreasing order, so we in the same order we can selected the items. So here also, after arranging all the items in profit by weight decreasing order, select the items directly. Whatever the order now rearrange. In that rearranged order, select the items. Now make it as first item, second item, third item. So this is for now. After arranging all the items, this is becoming W1, W2, W3. This is becoming W1. This is becoming W2. This is becoming W3. This is P1. This is P2. This is P3. This is P3. Okay, na? Then select first item now. Select this item. Of course, otherwise you can keep this one only. Nothing wrong. You can keep this one. Okay, na? What is W2 by P2 now? W2 by P2 is 1.6. Now select the second item. That means second item means in this rearranged order first item. Or you can keep second item as is, third item as is, fourth item, first item as is. Okay, na? Suppose. Now you need to select this item completely. This item is W2. What is W2? W2 is 15. W2 is 15. Okay, na? If W2 is 15, what is X1 now? X2 now? Of course, take the same nominations, no problem, same names. So what is X2 now? X2 is 1 because WT is 15, remaining knapsack capacity is 20 because initially we started now 20. This initial knapsack capacity is greater than 15, then we can completely consider item. Then weight included into knapsack is W2 X2, that is 15 into 1 equal to 15. Then what about profit we can obtain from this? P2 X2. What is P2? 24 into 1 is 24. This is the profit that we can obtain from second item. Then what about next immediate item? That is the third item in the original problem. Then 15 units have already consumed. What is remaining capacity? Remaining capacity is 20 minus 15, 5 units. What is the item weight? 10 units. Then what is the solution now? What is the solution? Solution is how can we construct solution if the remaining knapsack capacity is less than item weight? Just take remaining knapsack capacity as numerator and remaining weight as denominator. X equal to 5 by 10, that is equal to 1 by 2. Then we cannot get complete profit now because we extracted only half of the weight. Then profit also we half only. Then P3 X3 equal to 15 into 1 by 2. 15 into 1 by 2 is 7.5. Okay, na? So from these two items, we can fill the knapsack completely because 5 units we have extracted. Whatever the remaining weight of the knapsack, we extracted 5 units. Then 15 plus 5, 20. Now knapsack is filled completely. Then we cannot extract the third item. Third item means first item in this order. X1 equal to 0. X1 equal to 0. Then what is the solution now? X1 equal to 0. X2 equal to 1. What is X3? Half. So this solution is producing optimal because P1 into 0, P2 into 1, P3 into half, P1 into 0, P1 into 0, 25 into 0, 25, 0 plus 24 into 1 plus 15 into half, 31.5 we get. Even in first table, we have selected 31.5 as the optimal solution. So here also, according to this approach, we can get optimal solution as 31.5 because 0 into 25 plus 1 into 24 plus half into 15 we get 31.5, and the solution is x1 equal to 0, x2 equal to 1, x3 equal to half. Then we can represent solution as x1, x2, x3 equal to 0, 1, comma half. This is the solution finalized from this particular problem. Okay, now so like this we can solve the problem. Now I am going to explain the algorithm for this knapsack problem. So this is the algorithm for greedy knapsack problem. So first initialize all the solutions at 0. So x1 equal to 0, x2 equal to 0, so on xn equal to 0, because so here we are so whenever any item which is not going to be completely fit, we are extracting fraction from that. After that we are stopping. Then what about the rest of the items? So that's why actually rest of the items are 0. So that's why, so for keeping all the remaining items 0, we are initializing the solution at 0 initially. We are initializing solution at 0. So x of 1 equal to 0, x of 2 equal to 0, so on x of n equal to 0. So for this particular procedure especially, we are assuming that all the elements are arranged in this order, profit by weight in decreasing order. So Pi plus 1 by Wi plus 1, like that. So P1 by W1 greater than or equal to P2 by W2 greater than or equal to, so on Pn by W1. In this order we arranged all the items. That is the assumption. And initialize all the solutions at 0. Suppose if knapsack capacity is m, initially we have not yet selected any item. Then what about remaining knapsack capacity? Here unused, U is unused. So remaining knapsack capacity is initially the capacity of the knapsack. U equal to m. Now start selecting one by one item. Then you can directly select all the items in the same order because all the items have already arranged in profit by weight decreasing order. So that's why we can start selecting from the first item. Now start selecting from the first item. Now select first item and immediately verify whether the item weight is greater than knapsack capacity or not. Item weight is greater than knapsack capacity or not. If item weight is greater than knapsack capacity, then we cannot fit because remaining knapsack capacity is U units. Item weight is greater. I have already told in earlier example, in previous solution, if item weight is greater than knapsack capacity, we are going to calculate fraction value. Otherwise, we directly make, suppose if Wi is less than or equal to U, you can completely consider the item. Then completely consider means the respective solution is 1. Once after considering the item completely, earlier remaining knapsack capacity is U. What about updated knapsack capacity now? Earlier knapsack capacity before placing this item minus item weight. Suppose before placing this item, remaining knapsack capacity is 10 units. Suppose ith item weight is 5 units. Then the remaining knapsack capacity is 10, item weight is 5. Then we can directly place item completely because remaining knapsack capacity is greater than item weight. So after placing the item completely into knapsack, what about remaining knapsack capacity for selecting remaining items? 10 minus 5, that is 5. So we are going to use these 5 units for selecting next item. So like this we can calculate remaining knapsack capacity. So repeat this procedure until reaching this condition. Suppose still we are getting Wi less than or equal to U, then immediately make the respective item solution as 1 and we need to update the remaining knapsack capacity. Otherwise, suppose if Fi is greater than or Fi, if Wi is greater than U, means the current item weight is greater than U, then immediately calculate fraction. How can we calculate solution? I have already told. Remaining knapsack capacity by item weight. I have already told. Suppose 2 units are remained and item weight is 15 units. I cannot fit 15 units item completely into 2 units capacity bag. Is it clear now? The remaining capacity is 2 units, so now 2 kgs. It accepts only 2 kgs now. Now, but the next item weight is 15 kgs. How can I construct the solution? Remaining knapsack capacity by item weight. That's what I wrote here. So 2 by 15. So U by W of I. So this is the general the procedure. This is the procedure for breeding knapsack. So in this way, if you approach, then we get the optimal solution, because we initially consider the assumption as if all the elements are arranged in profit by weight decreasing order. If we follow this particular approach, we get the optimal solution. So this is about greedy knapsack problem. In the next video, I will tell you about the next example. Thank you for watching my video.